II. This is section 4.6, which is solving polynomial equations. Solving polynomial equations is like factoring. That's what we're doing for this entire section. And I'm going to treat this section a little bit differently. We're going to do this first example here, and then we're going to complete this box and talk about this box a little bit. And then I'm not going to use example 4 or the back page. I'm going to create my own examples. So kind of stick with me, and I'll make up my own examples as we go through here as I teach you section 4.6. So the first piece that we talk about is the sum and difference of cubes, and these are the two formulas that you have. This one's for sum because you're adding, and this one's for difference because you're subtracting. I do not have these two formulas memorized. I don't really expect you to either, and in fact I don't think this part is even on your homework assignment. But I do want to go through one of the examples with you so that you can kind of see how it works. It could help you with it do a shortcut later on. So a cubed plus b cubed, if you have something that's in the form of a cubed plus b cubed, like let's say I had x cubed plus 8, okay? I can take the cubed root of x cubed. The cubed root of x cubed would just reduce down to x, and the cubed root of 8 would be 2. So that's in the form of x cubed plus b cubed. It's in the form of 2 cubed plus, or x cubed plus 2 cubed, okay? So in this case, a would be x and b would be 2, all right? So to write out the factored form of that, I would just take a plus b, where a is x, so it would be x plus 2 for a plus b, and then it would be a squared, which is x squared, minus a times b, which would be 2 times x, or x times 2, plus b squared, and b is 2, so 2 squared is 4, and it would look like that. And this would be the complete factored form of x cubed plus 8 cubed. That would be an example of when you would use the sum of 2 cubes to reduce it down. If it was x cubed minus 8 cubed, you would use this formula, and put the symbols would just be changed. So this would be a minus instead of a plus. This would be a plus instead of a minus. I'll do another example down below here. Like part A, I want to use one of the sum of 2 cubes or difference of 2 cubes. And this one is a sum again because this is plus, okay? So I'm going to use that sum of 2 cubes, and I have to figure out what A is, and I have to figure out what B is. But before I do that, I'm trying to look and see, this is supposed to be the sum of 2 cubes, but I see a 4th power here. And that doesn't work because that's not cubed. But what I do know is this piece right here and this piece right here both have an x in it. So what I can do is I can pull that x out in front and rewrite what I have left over. I also see that 16 and 54, those are both divisible by 2. So let's go ahead and pull a 2 out in front also, okay? If I take a 2x out of 16x to the 4th power, I'll have 8x cubed left over. And if I take 2x out of 54x, y cubed, 2 out of 54 is 27. And if I take that x away, I'll just be left with y cubed, okay? So now I'm looking at factoring down this part, 8x cubed plus 27y cubed. That's going to be my sum of 2 cubes, okay? If I take the cubed root of 8x cubed, that's 2x. That's going to be like what my a is. And if I take the cubed root of 27y cubed, that would leave me with 3y. And that's going to be like what my b is, okay? So for up here, for my formula, I want to take a plus b. And if a is 2x and b is 3y, a plus b would be 2x plus 3y. Okay, that's what this first part's going to be, okay? Then I want a squared, okay? And a squared is going to be like 2x squared. But if I take 2x and I square it like this, that would actually be 4x squared, okay? So I'm going to write it like that. Then I have minus a times b. A is 2x and b is 3y, so 2x times 3y is 6xy. That's this ab. And then I have plus b squared. So plus b squared, I want to take 3y and square it. But 3y squared is actually going to be 9y squared. And that's what he will look like completely factored down. Oh, except I missed something. Shoot. I forgot about this 2x on the front, so I'm just going to lump this 2x onto the front of it, and that's going to be the entire piece here. So 2x times 2x plus 3y times this trinomial here. That's what he would be factored down. Again, I don't expect you to memorize that formula, and this was kind of tricky to factor down, but it could give you a shortcut later on. Okay, now I'm going to go back up, before we do part B, back up to the star, star, star. It's the polynomials that cannot be factored are called prime polynomials. Sometimes you aren't able to factor a polynomial down, and that's okay. In fact, that's really nice because you can just write the word prime and you're done. Okay, that falls into like this next example. Okay, I want to try to use the sum of two cubes formula here because this is y cubed and this is x cubed. But I have to look at the numbers in front, 8 and 5. I can take the cubed root of 8. The cubed root of 8 is 2, so that would work. But I can't take the cubed root of 5. There's nothing that I can multiply by itself 3 times to get 5. So that makes this invalid, and it is prime, and I cannot break him down any further. Okay? All right, now, I want to go down to these factoring techniques down here. And we've talked about each one of these four before. The first one is the greatest common factor. The second one is the difference of two squares. This 30-term chunk right here, these are simple trinomials. And this next one is complex trinomials. Okay. When they talk about the number of terms, down here it says 4 or more terms. 4 or more terms, it's a trinomial because it has 3 terms, but when we factor complex trinomials, we actually turn them into something that has 4 terms. So I'll do an example of one of those, okay? So I'm going to do one example of each one of these, and then we will be good to go, okay? So my greatest common factor example. GCF. I'm going to put that over here to the side. GCF. Let's call this 5x cubed plus 30x squared. And we want to try to pull out a greatest common factor. So what I noticed in that, in those two pieces, this piece and this piece, is that I can take a 5 out and both of them have an x squared, okay, that I can pull out. If I take 5x squared away from 5x cubed, that'll just leave me with an x. If I take 5 away from 30, that will give me 6. And x cubed away from x cubed, that'll leave me with nothing. So this is him completely factored down. On your homework assignment, it will just say factors, so if you leave your answer like that, that is totally okay. If you're one of those people that want to set them equal to 0 and find an answer, here's how you do that, okay? If this was set equal to 0, you would say 5x squared equals 0, and x plus 6 equals 0. You would set both pieces equal to 0, okay? Now to solve 5x squared equals 0, you divide by 5 on both pieces, okay? And x squared would be equal to 0 divided by 5 is still 0. And then to get rid of the square, I take the square root. And the square root of 0 is still 0. So my answer is x equals 0. To solve this one on the right side here, a lot of you guys can do that mentally. If I subtract 6 from both sides, I get x equals negative 6, and I'm done, okay? So you can write your answer like that, or if you just factor him down and leave him like that, that's a-okay too, all right? So that was a greatest common factor example. Ooh, that took up a lot of space. Now the next one I'm going to use, is a difference of squares, and I'm just going to write it DOS, okay? And a difference of squares, let's do this one. Let's do 36y squared minus 25. I'm going to do that, okay? Now, we can look at this and say, can I take the square root of 36y squared? Yes, you can. The square root of 36 is 6, and the square root of y is just, or y squared is just y. So I write 6y and 6y. Can I take the square root of 25? Yes, I can. It is 5 and 5. And one of these will be plus, and one of those will be minus. And that's the difference of squares. Super, super easy. Those are the ones that I love. Those are my favorite out of the 4 types, is the difference of squares. Now, I'll go through factoring this down, or setting this equal to 0 really quick. If I set 6y plus 5 equal to 0, I would subtract 5 from both sides, so 6y equals negative 5. and then divide by 6. Some of you guys can do this in your head, and that is awesome. So negative 5 over 6 would be the answer. If I set 6y minus 5 equal to 0, it would just be y equals positive 5 over 6. You can either do the math and solve it completely out, or just know that it's the opposite sign. Okay? Next example. Let's do this in a different color. Let's do this simple trinomial. I'll move this down here. Simple trinomial. Okay, here's the third one in that box. Simple trinomial. And my example for this one, let's use y squared plus 14y plus 48. Okay, just because there's y's doesn't make any difference. Kind of like this difference of squares one. Sometimes it'll be x's, sometimes it'll be y's, sometimes it'll be z's. You just use the variable that they're given. So don't let that intimidate you if it's not an x. It's okay. So for a simple trinomial, all we're asking ourselves is what can I multiply together to give me 48, but when I add them, give me 14. Okay, so we're trying to figure out things that multiply together to give me 48. If you cannot think of them, I just write them in a box. 1 times 48 will give me 48, but I can't add those together to give me 14. So let's think of something else. 2 and 24, those don't add up to be 14 though. 3 and 16. 3 and 16, nope, that doesn't quite make 14. 4 and 12. 4 and 12, nope, don't quite make 14. 5 doesn't go into 48. 6 and 8. That's what it is. 6 plus 8 will give me 14. So what I do is it's got to be a positive 6 and a positive 8 to give me positive 48 when I multiply them and a positive 14 when I add them. So it's just going to be x plus 6 and x plus 8, and that's what he looks like completely factored down. Okay. If you set both of those equal to 0, like if I set x plus 6 equal to 0, x equals negative 6, and x equals negative 8 when I move those over. Okay. So you can either write it just in the factored form, or you can write it setting equal to 0. I will take both of the answers. Okay. All right, the last one, I'm going to put him over here. This is going to be a complex, so I'll give myself some room. Complex trinomial. All right, complex trinomial is the last one, and let's do 4x squared plus 7x minus 2. Okay. Now, I forgot to say this over here on simple trinomial. The reason why he's simple, and I know I've said this before, the reason why he's a simple trinomial is because it's just y squared here, or just x squared, or just that variable square. There's no number in front of him. That's what makes him simple. Okay. The reason why this guy is complex is because there's a 4 out in front of here. That's bad. We don't like it when that happens because there's more steps that we have to do. Okay. All right, so when we're doing a complex trinomial, I look at this first term and I look at this last term and make sure that if there's a sign, he goes with him, okay? And I take that first term times that last term. 4 times negative 2 is negative 8, okay? And I put it in like a little T box, all right? So then you ask yourself the same questions you asked yourself over here. What do I multiply together to give me negative 8, but when I add them, give me 7, okay? Well, I know that 1 times 8 will give me 8. But which one of those has to be negative in order for me to get a positive 7? Well, 8 has to be positive and the 1 has to be negative. So let's check this in my head here. Negative 1 times positive 8 will give me negative 8. And negative 1 plus 8 will give me positive 7. That's what I want, okay? So now, I write this complex trinomial in 2 pieces. Or, excuse me, in 4 pieces. 4x squared minus 2, those 2 pieces stay the same. But this 7x is going to break down, and it's going to be written with these 2 guys here. I will write minus 1x plus 8x. So that 7x will break down into those 2 pieces. If I go in the reverse order, if I'm going from here up to here and combining those 2 terms, I should get 7x. Negative 1x plus 8x gives me 7x. We're good. Okay. All right, let's use a different color here. I'm going to group these first 2 pieces. That's why grouping up here, that's why they called it grouping. You're factoring by grouping, okay? All right, I look at this piece and I say, what can I take out? Well, they both have an x in it, so I'm going to pull an x out, and I'm left with 4x minus 1, okay? Then I look at the second piece, and I can take a 2 out, so I do plus 2, okay? And if I take 2 out of 8x, that gives me 4x. And if I take 2 out of negative 2, that gives me negative 1. Okay, If at this point these two pieces in parentheses do not match up with each other, you did something wrong, okay? If I take that 4x minus 1 out, I am left with just x plus 2, right? And this is what he looks like completely factored down. You can leave your answer like that, or you can set it equal to 0. If you set this equal to 0, let's see if we can do this in our head. If I set this equal to 0, I'm going to add the 1 first, and then I'm going to divide by 4. So that would be 1/4, positive 1/4. And if I set this guy equal to 0, I'm just going to subtract the 2 over to the other side. So x is equal to -2. Okay, that's what he looks like if you set him equal to 0, right? And those are the 4 types. I know we've done this before, and I'm beating a dead horse, but I really want to make sure you guys know this. You're going to be doing some more of these for your homework problems, and that's what we're going to cover for section 4.6. All right, I'm not going to worry about this example or the backside. That's for another day. Okay.